Okay, we're doing number 7, and we're going to find all of these things. We're going to find our H sub O, our H sub A, our test statistic, p-value, critical value, and then state the conclusion. These are the basic steps that we're always going to go through, but they're varying what we're trying to test here. So here, they're talking about the same problem that was the chapter problem, but now we're going to use a difference between passenger cars and commercial trucks. So they're saying we have these stats among 2,049 Connecticut passenger cars, 2,039 had only rear license plates. Among 334 Connecticut trucks, 45 had only rear license plates based on samples collected by the author. A reasonable hypothesis is that passenger car owners violate license plate laws at a higher rate than owners of commercial trucks. Use a 0.05 significance level to test that hypothesis. So we're going to test the claim using a hypothesis test and then test the claim by constructing an appropriate confidence interval. So for A, we're going to do that one first, and we've got all of our data here, and we're going to use, since this is a proportion test, from 9.1, we're going to use our 2 proportion z-test to do this one, and I've set it up for you on my calculator. Here we go to stat and test, and we go down to 2 proportion z-test, and now I will hit enter. I've entered the data, 239 out of 2049. The x sub 2 is 45 out of 334. And then we're going to use the P1 is greater than P2 because the first one is the passenger cars and the second one is the trucks. So we're just getting our relationship right there. Then we're going to move down to calculate, hit the calculate button, and we get a z-score of negative 0.946. and a p-value of 0.82979 or 0.8280. Here is my data board. Now down here are my scores. Z is negative 0.946. That's my test statistic. P-value is 0.828, and my Z sub C, which is my critical Z-score, is 1.645. Now, notice that we have 0.05 as our alpha, but our alpha is in one tail, not 2 tails. So we have 0.05 in one tail, which means, remember these confidence levels down here have the data, the alpha split into 2 tails. So since I have a 0.05 in one tail, that's going to be the same as a 90% confidence level, because 90% would have 0.05 in each tail. So I'm going to use the 1.645 as my critical value, not the 1.96 that goes with 95, because that 95 is split into 2 tails. That 90 is split into 2 tails, which means 0.05 in a tail, and 1.645 is my correct critical value. Now I compare my test statistic of negative 0.9 with my critical value, which is going to be in the right tail, and I am going to say my test statistic is nowhere near my rejection region. So I must fail to reject. Now let's look at the p-value. The p-value is 0.828. My critical value is 0.05. 0.8 is way larger, and therefore I failed to reject with the p-value as well. So when I fail to reject my H sub O, that means that I'm pretty much assuming that it is true, and the claim, which was this one, has not got enough evidence to support it. So we would say there's not enough evidence to support the claim that passenger car drivers disobey the law more often than the trucks do. So now we're doing the same problem, but we're doing the B portion, and they tell us to test the same situation with a confidence interval. So now remember the original situation. We had 0.05 in one tail. Remember, confidence intervals have the same area in both tails. So if we wanted a confidence interval that was equivalent to 0.05 being in one tail, we would have a 90% confidence interval, because a 90% confidence interval would have 0.05 in each tail. So we're going to choose 90%. We're going to choose to do a 2 proportion Z interval. So I'm going to type that on my calculator, but this is what you're looking at getting. And here's the calculator work. So now I'm going down, because I'm doing a confidence interval on a proportion. I'm going down to 2 proportion Z int. Okay, so now I'm going to click enter. I'm going to enter my data, and notice that I've entered a confidence level of 0.9 instead of 0.95, and now I'm going to calculate, and there is my confidence interval. Now, if 0, remember we're testing the difference between the proportions. If 0 is inside the confidence interval, then we have not got enough evidence that there is a difference, because the difference of 0 is in the confidence interval from negative 0.051 to positive 0.01478. There's a 0 in there, and so P1 minus P2 could be 0. Therefore, we have not got enough evidence to suggest that there is a true difference in there. So we're getting the same result we did before, but we're doing it a different way using a confidence interval. So exercise 7 on 9.2 says, color and creativity. Researchers from the University of British Columbia conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Responses were scored by a panel of judges, and results from the scores of creativity were given below. Higher scores corresponded to more creativity. The researchers make the claim that blue enhances performance on a creative task. Use a 0.01 significance level to test the claim that blue enhances performance on a creative task, and then construct a confidence interval appropriate for the hypothesis test in part A. What is it about the confidence interval that causes us to reach the same conclusion from part A? So we have red background, blue background, and we have the statistics there. So we can do so this is talking about a mean here, not a proportion. Okay, so we're talking about a mean, and we have an X bar and an X bar 2 there, and we're going to test the means to see if the claim is true that blue makes you more creative than red. So here is my board. Okay, so I let my H sub A be red is less than blue, or creativity with red is less than creativity with blue. My H sub O is red is greater than or equal to blue. The H sub A is my claim. Now, my T statistic and my test statistic and my P value came from my 2 sample t-test, which I will show you in a minute, and my critical value came from my inverse t. So basically, I've got, my situation is one-tailed, and I've got 0.01 is my critical value, so it's all in one tail. So I want 0.01 in one tail, and when I do that, and I put inverse t 0.01, now remember I had two 35 and 36 were my two sample ends. And so I take the smallest one and I subtract 1 from it, and I got the 34. So I put in inverse t And then in the parentheses, I put 0.01 because that's in one tail, and I put comma 34 because that's my degree of freedom. And I put a parenthesis and I got negative 2.441, which is correct according to the book. And then to get this, I used my 2-sample t-test. And I put in all of the data, and I got out t is negative 2.979 and p is 0.0021, which are also correct according to the book answers. So now we have to make our decision. So let's make a decision from our p-value, and we got 0.0021, which compares to 0.01. And 0.0021 is less than 0.01, therefore we should reject H sub O. So let's look at our scores. We got a test statistic of negative 2.9 and a a critical value of negative 2.4. Negative 2.9 is in the tail. So again, we reject H sub O. Let's look back. What was H sub O? H sub O was that red had greater than or equal to creativity than blue. Since we reject H sub O, that means we have enough evidence to accept or support the claim that people with red backgrounds have less creativity than people with blue backgrounds, or blue backgrounds have more creativity than people with red backgrounds. And so that is the A portion of 9.2 number 7. And now we're supposed to do the same thing with a critical, a confidence interval. So we will come back to that now. So again, since we have a 0.01 in one tail, that's going to be the same thing as a 98% confidence level, because the 98 would have 0.01 in two tails. So we're going to use 0.98 as the confidence level or the interval. Well, here is my board. What I did was I went to a 2-sample t interval. And I didn't even have to type in the data again. It just appeared because of my hypothesis test that I had just done. And when I put in a 98% confidence level, because of the 0.01 in each tail would give me a 98, then I get negative 1.046 and negative 0.1142 as my confidence interval, and they're both negative, which means that there is a difference, and it appears that, as claimed, the blue leads to more creativity than the red, and that is the end of problem 9.2 number 7, and we move to the last one. And the last video problem that you're going to see in this class. Do I hear applause? Here is Oscar Hypothesis Test, Example 1 on page 444 in this section. Uses only 5 pairs of the data from set 14, Oscar winner age, in Appendix B. Repeat the hypothesis test of Example 1 using the data given below. Use a 0.05 significance level in the example. Construct the confidence interval that could be used for the hypothesis test described in Part A. What feature of the confidence interval leads to the same conclusion reached in Part A? Okay, so now remember, we're in 9.3 now, and we have to actually enter the data into 2 columns of our calculator. So we're going to put actresses in L1 and actors in L2. So I've entered the data, L1 and L2, from my data here. And in L3, I'm going to, notice down here, I'm going to engineer this to where it's got L1 minus L2 in it. And when I hit enter, then all of these values will calculate. So let's hit enter. Isn't that cool? So now it has been subtracted for me. Now I'm going to run a one variable stats on L3, and this is what I get when I do so. So I have my X bar, which is negative 9.7, and I have my S of the difference, which is 11.757. Okay, so we had our X bar and our S from our calculator. We did our one variable stats and got that. Okay, so here, this is how I got my critical value. I went to my inverse t and I put a 0.05 because it is a one-tailed test. I put my 0.05 in one tail, and since we had 10 items in our sample, I have a degree of freedom of 9, and my computer gives me back negative 1.833. So that is correct. I checked it with the answers. That is my critical value. Set up my t-test using the data that they gave me, and I chose less than because I should. It's a left-tailed test. Now I'm going to calculate. And negative 2.609, and P is 0.014. That's my T and my P, which I put here on my screen. And so now we're doing our test. Is the mean really less than 0? Now the mean less than 0, the mean for actresses is less than the mean for actors, or the difference in the two means is less than 0 is the question. And now this right here would be my H sub O. So greater than or equal to 0 would be, my H sub A, excuse me. So greater than or equal to 0 would be my H sub O. So let's see what it says here. If we're going to do this with the t-scores, we have negative 2.6 is much more unusual than the critical value, therefore it is in the rejection region. And 0.014 is much less than 0.05, and again, we must reject H sub O. So we will reject that actresses are greater than or equal to actors, and we will say that there is enough evidence to support that in general actresses are younger than actors in the sense of this problem's question. And that is number 5 on 9.3, but it has a B portion, which is involving the confidence interval again. So I go to do my t-interval test. My data popped up in there. I did not have to enter it over again. This is so much fun because the calculator's doing it for me. And I wind it with negative 16.52 and negative 2.885, which matches the book's answer right there pretty closely. The confidence interval consists of negative numbers only and does not include 0. Therefore, we agree that the difference is real, and there is the mean is less than 0. We be done with videos. This is Mrs. A, and may God bless your day.